You know, we're always told to eat our fruits and veggies, but what if those plants are actually fighting back? Today, we're going to pull back the curtain on a hidden chemical war that's been going on for millions of years, and it's happening right in your kitchen. So, let's kick things off with this really provocative quote from Dr. Anthony Chaffee. Plants are trying to kill you. Whoa. I mean, that's a statement designed to grab your attention, right? It forces you to look at that salad on your plate a little differently. So, what's the deal here? Is that just an exaggeration to make a point? Or is there some real, hard evolutionary science behind it? Well, that's exactly what we're going to get into today, the surprising and hidden world of plant defenses. All right, here's our game plan. First, we're going to cover why plants even need these defenses in the first place. Then we'll dive into some of the key players, these sticky little proteins called lectins. We'll look at the shocking places you can find cyanide. Then we'll talk about nutrient blockers, and we'll wrap it all up with a look at the famous nightshade family. Okay, first things first, let's tackle the big why. I mean, why would a plant go to all the trouble of producing toxins? Well, it all comes down to this silent, ongoing battle for survival that scientists call the evolutionary arms race. Think about it like this. An animal can run away, it can fight, it can fly. But a plant, it's literally stuck in one place. So its only real strategy for survival is to get creative with chemistry. Plants have developed this massive arsenal of chemical weapons to deter, harm, or even kill anything that tries to eat them. The whole process is just brutally simple when you break it down. An animal shows up, the plant can't run, so its only option is to fight back with chemistry. Honestly, this is the main reason why you can't just walk out into the woods and eat any random plant. Most of them are absolutely loaded with these defense chemicals. All right, let's dive into our first category of these chemical defenders. They're called lectins. Now, these are basically proteins found in a ton of plants, and their whole job is to be sticky and just cause trouble on a cellular level. Lectins are pretty sneaky, and they work in a few different ways. First, they can actually stick to the receptors on your cells, like the ones for insulin or leptin, which can totally scramble your body's signals about metabolism and whether or not you're full. Second, they can cause physical damage to your gut lining, potentially leading to something people call leaky gut. And finally, and this is a big one, some lectins can look so much like our own body's proteins that they trick our immune system into attacking itself. That's a process called molecular mimicry. And this is where it gets really wild. The vagus nerve is like a super highway connecting your gut to your brain. Some research suggests that lectins might be able to travel up this nerve. In fact, one source points to this study from 2015 that found people who'd had their vagus nerve cut years ago for ulcer treatments actually had a significantly lower risk of developing Parkinson's disease. It's a really fascinating potential connection. All right, next up, we have a chemical that pretty much everyone recognizes as a poison, cyanide. And what's crazy is that thousands of plants actually use it as a defense mechanism, including some that are major food sources for millions of people. So here's how it works. The plant stores these compounds, called cyanogenic glycosides, pretty harmlessly inside its cells. But the moment the plant gets damaged, say when you chew it, a chemical reaction kicks off that releases hydrogen cyanide. A perfect example is cassava root. Over 500 million people rely on it for food, but it has to be prepared so carefully to get rid of the cyanide, because long-term exposure can lead to thyroid and neurological damage. And just to put this into perspective for you, this number, 400 to 800 grams, that's about how many almonds it could take to deliver a lethal dose of cyanide to an adult. It's a pretty stark reminder of just how potent these hidden chemicals can be. Okay, our next group of plant defenses is a bit more subtle. These guys aren't an outright poison, they're more like saboteurs. Often called anti-nutrients, their job is to stop an animal, or us, from getting any of the good stuff from the food. And they each have their own strategy. You've got oxalates, which you find in a lot of leafy greens, and they can literally bind to minerals like calcium, making them unusable and sometimes contributing to things like kidney stones. Then you have tannins. That's what gives tea that bitter taste, and they can mess with your digestive enzymes. And finally, phytates, which are all over greens and legumes, grab onto minerals like calcium and magnesium and just don't let go. And this is so important to understand. It means that a nutrition label doesn't really tell you the whole story. The presence of these nutrient blockers means the bioavailability, that is, what your body can actually absorb and use, might be way lower than what the numbers on the package claim. All right, for our final category, we're going to look at a family of plants that I guarantee most of us eat every single day, the nightshades. This group includes some of our favorite foods, but also some of nature's most well-known poisons. I mean, just look at this list. The range is incredible. You've got potatoes, tomatoes, eggplants, and then on the same list, you have tobacco and the infamous deadly nightshade. The thing they all have in common is a type of toxin called an alkaloid, and one of the big ones is solanine. Okay, this brings us to a piece of kitchen advice I bet a lot of you have heard before. But here's the thing. It's not just some old wives' tale. It's a direct result of the plant's chemical defense system kicking into high gear. That's exactly right. See, when a potato gets exposed to light, it starts producing chlorophyll, which is what turns it green. But at the same time, it also massively ramps up its production of the toxin solanine. So that green color is basically nature's little warning sign, telling you that the potato's chemical defenses are on full alert. And this is where things get really interesting, because you see this clash between traditional wisdom and modern advice. For generations, people figured out how to prepare these foods, peeling potatoes, skinning and de-seeding tomatoes, specifically to get rid of the parts with the most toxins. Nowadays, we're often told to eat the skin for the nutrients, maybe forgetting that the skin is also the plant's first line of chemical defense. So after all this, after looking at lectins, cyanide, nutrient blockers, and solanine, here's the final question. Once you realize that plants aren't just these passive things full of vitamins, but that they're active players in an ancient war armed with this incredibly complex chemical arsenal, how does that change the way you look at the produce aisle? It's definitely some food for thought.